Um, this is a webinar on skimmer basin design. For those of you that have joined us before, some of it may be similar. Hopefully we've got some new folks on here. If you would, looks like most of you are muted. Feel free to use the chat to ask questions as we go along. We'll try to keep an eye on those and answer those. And then we'll also have a brief time at the end. We'll also record this. And so if you have any questions, want to look back, this will be available on our YouTube channel. So my name is Jamie McCutcheon. I am the owner of Rymar Waterworks. I'm a 92 graduate of Clemson University in civil engineering. I own CCAD engineering for about 20 years. So I've done hopefully what many of you have done as far as design work. And then I invented the Marley float skimmer back in 2013. And I am a licensed professional engineer in South Carolina, North Carolina, and Georgia. And just to help with the video recording, I'm going to cut my video off now. So when we do the recording later, it will show better. There we go. All right. So today we're going to go over an introduction to skimmers or floating outlets, as they're called in some areas. We're going to go over the basics of skimmer basin design, how to use a skimmer for post-construction. We'll talk about if you're going to do it for post-construction, how to model it in hydroflow. And then we're going to finish up with our Rymar water quality filter and filtration based design. So just to get me kind of know who our crowd is today, how are you familiar with skimmers? There should be a poll launched if you could answer that. So I know kind of the depth to go into as we go through this today. So it looks like got a good many have answered. Most are somewhat here to learn more. So glad you joined us. Got a few that are very used to them. Hopefully we'll give you some information you can use today, and then 4 or 5 that are new. So appreciate you being here, and hopefully this is informative for you. So we'll do that, share that result real quick, stop sharing, and we'll move on here. So what we used to do is have a riser structure, typically had a hole at the bottom of it, or maybe perforated holes, had a riprap check dam in front of it. But the idea was, we were releasing water slowly, but problem was we were releasing water from the bottom of the pond where the mud concentrations are highest. So in the past several years, we have switched over to skimmers being more common. So the idea with a skimmer is that it floats. It takes in the water from near the surface or at the surface, which is typically cleaner than the water at the bottom, drains the basin from the top down, and gives the mud more time to settle. The Marley float's a little bit different. It's got a debris guard around it. So water kind of comes under that debris guard, and then there's an intake about 3 to 4 inches below the surface, and we let the water in from there. So one of the advantages of that is that debris guard keeps debris from the inlet or intake portion, the grate, and less prone to clogging because of that. There are a variety of skimmers on the market. The Faircloth skimmer is probably the most common. They've been around the longest. The erosion supply or ESC skimmer is kind of similar to the Faircloth in design. The IAS skimmer is one out there, and then the Marley float. So not sure how many of you actually seen a skimmer in action, but this is a basin in Anderson, South Carolina that was right after a big storm. This is right next to Lake Hartwell. So, the outflow there, you saw the water in the pond was pretty muddy, but what's coming out is relatively clean. So just a good example of how effective a skimmer can be by releasing that water from near the surface. And in this case, we're about 100 yards from the lake. So it was very important to keep the lake clean as possible and not have a lot of turbidity going there. So we'll go over the basic fundamentals of sediment basin design. There are basically 3 fundamentals. So number 1 is the basin volume. So the basin volume is going to be based on the area flowing to the basin. Regulations do differ across the country from state to state, and even sometimes within the state. The general standards we see, the most common, are either 1,800 or 3,600 cubic feet per acre of volume for flowing to the basin. So for example, if you had a 5-acre site and they were in an area required 3,600 cubic feet, that'd be an 18,000 cubic feet required volume. Now, some areas such as Ohio, Indiana, and Texas also require basins to have a permanent pool volume or sediment storage volume. That's typically below the inlet or the stub out of the pipe or the lowest elevation of the skimmer. And so very important when you're designing your or selecting your skimmer that you use the required volume for that selection, not the actual volume to size the skimmer. Often if this pond is going to be a detention pond, permanent pond later, that pond may have an actual volume 5 times, maybe 10 times what's required for your sediment control. And if you use that larger volume, you're going to release that required volume too fast. So the next fundamental is dewatering time. Now this also does vary from state to state. It also is varied based on the type of soil you have. If you're in an area that's got more coarse, sandy soils, things are going to settle much quicker. If you're in an area with silts and clays, things that stay suspended, obviously it's going to take much longer, although that's a relatively low mass amount in the water. But our general standard, the kind of the most common we see is 2 to 5 days or 48 to 120 hours. But, some areas require less, some areas don't set that. And your engineering judgments need to balance the need for extended times for soil types versus the frequency of rain events. So if you're if you're in the southeast and you're expecting that thunderstorm every afternoon during the summer, you want to make sure that you're draining the pond fast enough so you've got some volume in there. So maybe you don't want to go all the way out to 5 days, maybe stay closer to that 2 or 3 day time frame. And then the last fundamental is the flow rate. So once you know your basin volume and your dewatering time, it's pretty easy to establish your flow rate, just basin volume divided by dewatering time. Now you'll use the minimum dewatering time to determine the maximum flow rate and maximum dewatering time to determine the minimum. So for example, if you have a 2 to 5 day range, your flow rate could be anywhere from 9,000 cubic feet per day is your max flow to 3,600 cubic feet per day for your minimum flow rate. Now, one thing to point out is your lower flow rate often will be a smaller and typically less expensive skimmer. So sometimes if you're really cost conscious, you may want to go to a little longer flow rate to reduce that size. But again, it's really up to the engineer to determine what's best for the site within that range that's allowed. So we're going to do one more quick poll just to help me out to know, again, kind of where you're from. So I'm going to launch here a location poll. So I've got a few states on there and an other. So if you would just fill that in real quick. Awesome. Looks like we've got a good group from Ohio, a few from South Carolina, Georgia, Indiana, and a lot of others. So for those that are other, if you want to put in the chat where you are from, in the next section here, we're going to talk about some state standards. And I know we started a little bit late, so or to catch up on time, I may skip a few of those. Just kind of let me know where you are. So I'm going to end that poll, share those results real quick. Again, largest contingency today is from Ohio. Appreciate you joining. And then South Carolina, Georgia, and Indiana. And in the chat, we've got Kentucky, New Jersey. New Jersey, I did not include you today, but I appreciate you joining. Appreciate feedback in Ohio. And then we got some from Tennessee. So, all right. So next thing I'm going to run through really quickly here, some different state standards. Now, again, I've got more states in here than we're going to hit on today. So some of these I'm going to fly through. And some of them are similar, some of them are a little different. So we'll start with South Carolina, just because we're based in South Carolina. So one thing, typically every state across the board, and well, I won't say every, because there's probably something out there that's different, but most states say we're shooting for an 80% target for removal efficiency. And in South Carolina, we're basing discharge capacity on a 10-year, 24-hour storm event. Some are smaller storms, some are larger storms. Again, South Carolina has that 3,600 cubic feet per acre as the required sediment storage. And then the dewatering time is 2 to 5 days. One thing in South Carolina is it says the orifice size and associated flow rates are product specific and should be based off product specific testing. So one thing that people assume about skimmers is it's constant head and therefore constant flow. That's not really the case. Testing has shown that there is a flow rate curve to skimmers. And so a couple of states, South Carolina and Georgia specifically, now require that the skimmer sizing be based on flow rate testing, not just an orifice equation. Real quick, North Carolina. And North Carolina has this in their CGP, which most states do. It's a good example. It says sediment basins that receive runoff. Well, in North Carolina, it's 1 acre or more. So you use outlet structures that withdraw water from the surface unless infeasible. And it's very seldom that there's infeasible. Now, Lynn, our sales director, is in Minnesota right now, and it's frozen solid. So that would be a time where it may be infeasible. Those of you in Ohio, more the northern states, you may have times a year where it is infeasible because you're just, frozen. You got a foot of ice there. In those times, we would recommend you have an alternative outlet structure, maybe a valve, a perforated pipe with a valve on it that can be open when needed. So North Carolina, they're one of the ones that require 1,800 cubic feet per acre. And then they have a minimum dewatering time of 48 hours. Their max is 120 hours for 5 days. So again, dewater from the surface. And again, they have that 2 to 5 day time frame. And North Carolina does say any skimmer design that dewaters from the surface at a controlled rate is acceptable. So, people say all the time are you approved? And we do have a lot of DOT approvals, but most states don't approve specific skimmers. Georgia, just touch on it real quick. It has the same language about product specific testing in it. And then it has this table that you're required to show if you're doing plants in Georgia. So you got your top and bottom width and length. Time to drain. We recommend that you don't set a specific time. We recommend a range of 48 to 72 hours in doing that. And again, Georgia has that 67 cubic yards per acre. So that is 1,800 cubic feet per acre. I know we had a few people from Indiana. Indiana's skimmers are relatively new, so I haven't checked the IDM manual lately, but last time I checked, it still had draft across the Sediment Basin standards. Indiana has a required storage of 5,600 cubic feet per acre, so larger than most states, or the 1 year 24-hour storm. Now, depending on your site and where you're located, that 1 year 24-hour storm volume may be less than the 5,600 cubic feet per acre, so it may be worth running those calcs. And then Indiana also requires the additional sediment storage zone of 1,000 cubic feet per acre per disturbed acre. So the 5,600 cubic feet is in total acreage drained into your basin. So you may have some area that's not being disturbed. And then the sediment storage is 1,000 cubic feet per disturbed acre. Again, that's here. And then they say they want no less than 48 hours or longer than 72 hours. So they have a 24-hour range for the runoff there. And they have the same, withdraw from the surface of the water column with a floating outlet and provide alternatives for freezing time periods. And then again, the 1,000 cubic feet per acre. And again, this should not be included in the dewatering storage volume when you're sizing your skimmer. We'll skip through that because it's a lot of the same stuff. I don't know if we had anyone from Texas on here today. They have some similar requirements. And just because we started late, I'm going to jump through a little faster here. Okay, so here's a little chart that just kind of compares some state standards. We'll go through this quick. I know we had some from Tennessee on here. So Tennessee is one of those that requires 1,800 cubic feet of dry or like your volume that you're going to discharge, and then another 1,800 cubic feet per acre for wet or sediment storage that's not included in your volume. And then Tennessee has a dewatering time of 1 to 3 days. And also here we had some others. Ohio, we had there. So Ohio's 1,800 cubic feet per acre based on the total acreage drained into the basin, plus 1,000 cubic feet per acre for sediment storage. And Ohio has a 2 to 7 day time frame to do. So I mentioned earlier that skimmers in some areas are to be based on product specific testing. This is some a chart that was done by TRI Environmental when they did some study for Georgia. And they tested 3 different skimmers. They got a type 2, type 1, type 3 up here. And these are all 3-inch skimmers. And the test tank goes from 0 to 4 feet deep. And what you're going to see is that 2 of the skimmers start out really similar flow rate at 1 foot depth. and the other skimmer is almost double. And then all three of the skimmers, as you go from 1 foot to 4 feet, have an increase of about 25% of flow rate. Two of the skimmers, again, are close to the same flow rate. You know that this is in GPM, so around 50 GPM, and the other one's nearly double. So the main point here is if you just spec a 3-inch skimmer and you don't give more information to that, you may not get what you intended. You may have intended one that flows slow and get one that flows fast, or vice versa. So it's really important when you're putting the specs on your plans to specify flow rate in addition to whatever skimmer size is being specified. Now we have a tool on our website. Actually, we have a little, we call it our engineers pack that you can download that has all of our information in one simple download. But in there we have design tools. So we actually have two tools. We have one that is based on having just a dry basin, and the other one has a little bit of additional information for a wet basin. So you're going to put in your information here. So we've got a job, let's say in Charlotte. We're going to describe it as Sediment Basin 1. We've given you 2 other places if you need other information here. You know, it may be this basin is phased and it changes. You know, this is a phase 1 for Sediment Basin 1 and phase 2, whatever it may be. We have this little check right here. So what we have found talking to reviewers and some feedback is that engineers, the most common mistake with skimmers is that they size the skimmer based on the full volume of the pond. And so here's a check for your required dewatering volume. So in this case, 7.5 acres. And in North Carolina, we're at 1,800 cubic feet per acre. So that's 13,500 cubic feet is our required volume. So then we come down here and then we can put in a maximum time to drain and minimum. So we have that 5 days to 2 days. Pond depth. Now the pond depth is not necessarily your full pond depth. Your pond depth is whatever depth it takes to reach this required dewatering volume. So in this case, we're saying it's a 3-foot pond depth, our top length and width, and our bottom length and width. Now, I have seen very few perfectly square or rectangular basins. So use your engineering judgment to adjust these numbers. And we're going to calculate a pond volume. And what we recommend is that this pond volume is within about 5% of this required, okay? We're hitting a 3-day, range of time here. So we don't feel it's necessary to, dial this thing in exact and go to, 120.34 feet and 50.75 or whatever it is in order to get this to 13,500. So get it close. And then this spreadsheet, you can't read all these, but it's going to calculate the flow rate for all of our skimmers with each orifice. Now, at the bottom of this spreadsheet, there's a skimmer report page tab. You simply click on that tab and it's going to take you to a nice, neat 8.5 by 11. The top of this is going to have all your design information because have your information, your sediment basin number, your check here, and it's right here at your calculated. So it's really easy for you and your reviewer to check. It's going to calculate for you your minimum flow rate for your maximum time and your maximum flow rate for your minimum time. So you'll have that available so you can put that on the plans if needed. And then because it is our tool, it's going to tell you which one of our skimmers with each orifice meets your specified range of time. So in this case, we go from anywhere from 48 hours for a 4-inch skimmer with a 2-inch orifice to 111 hours for a 2-inch skimmer with a 1.5-inch orifice, all fall within that 48 to 120 hour time frame. We typically recommend to shoot for something close to 2 to 3 days. So in this case, I would probably recommend our 2-inch with a 2-inch orifice at 69 hours, so just under 3-day time frame. That does 2 things. One, it's a good time. That 3-day range is a good time to set. Also, our 2-inch skimmer is going to be less cost than the 3 or the 4. So you're going to save your client a little bit of money and hit the time frame that you need to hit. But obviously, time frame and that's probably more important than cost. But costs do weigh in. We also have some sediment basin details. We have 4 different details on the website. So we have details that just have a pipe through the dam. So this wouldn't have an outlet structure. Typically, this would be a temporary basin. Over here, we're going to have our criteria. We're going to have our length to width ratios if those required in your area. We're going to set the volume required. So this is going to be for whatever basin surface area required. And right here is where we set the minimum and maximum dewatering time. So the reviewer is going to review that and approve that, during the process. And down here at the bottom, we have a block for each basin. So you got your drainage area, disturbed area, your flow rate, basin volume required and provided, surface area required and provided, outlet information, barrel pipe, emergency spillway, elevation and width. Here you have your skimmer size, your skimmer orifice diameter, the skimmer manufacturer. You know, if you want to put in Rymar or Marley there, just keep it there. That's great with us, but we leave it blank for you. Is an equal allowed, yes or no? Typically, that's going to be yes. There may be some situations where it's a no. You know, if we'll talk about that a little bit later if you're going to use the skimmer post construction as well. And then you're going to set your skimmer flow rate min and max. So if you did say an equal is allowed and you got that flow rate set, it's a simple shop drawing review. If the contractor says, hey, I've got whatever skimmer left, you know, on my job or at my yard that I'd like to use, can I use it? Well, does that work? You know, yes or no, really quick to check that. You don't have to go back through a full review, typically with the reviewer, because obviously sediment basin and skimmers the first thing to go in on most projects. We have one for with a riser structure with a permanent pool. So it has a little more information on it. And then we've got a riser structure with a dry, and we have a permanent pool with a temporary. So we got all those available on our website in that one download. And then our detail, we have our detail for each skimmer available. Couple things to point out about our skimmer a little bit different than others. We have set orifice sizes. We have an orifice plate, or sometimes depending on the size of the skimmer, we may have multiple plates that have different hole sizes in them. We have a data chart up here. I know you can't read that, but that gives the flow rate for each skimmer with each orifice from 0 to 4 feet of depth. We provide with our skimmer a flexible coupling. The only thing the contractor or distributor provides is the pipe from the flexible coupling to the skimmer. One big question we get asked is how long should this pipe be? We recommend 1.4 times the height of your outlet structure, or if it's a temporary basin without a structure, the height of your dam. So we also typically say a minimum of about 8 feet. Sometimes you may have very short outlet structures. Maybe this outlet structure is only 2 feet tall. You want more than a 3 feet piece of pipe there. Just, you know, it just functions better when you got, 6 to 8 feet out there. Then kind of wrapping up our construction phase here. This is a pretty good picture of a basin. It's, sides have been tracked in. Obviously, I had a little bit of rain because it's got some water in the bottom. Baffles are in. One thing I like to point out here is this stone pad. What we would recommend here is you actually excavate this and create a depression here and have that stone set down a little bit. The reason is you're going to have whatever depth of water up to that stone and probably a little bit higher to get into the skimmer. And so it's going to be really hard to drain this basin completely dry, and assuming it's intended to be a dry basin, and hard to get grass to grow, if it's holding water over time. So if you're trying to get that thing stabilized early in the project cycle, now, we realize sediment basin is going to accumulate sediment, so it may have to be cleaned up, regrassed anyway at the end of the job. But that is one thing to point out where they didn't quite follow the detail, but otherwise they did a really good job putting this basin in. Now this is the exact opposite. They did probably one of the worst jobs. They've got no flexible coupling here. I'm not even sure how the pipe's attached to that little flange they have. If you look close, they've got this side open, so all the water's bypassing anyway. Just really poor install of a skimmer. This one as well. One, they installed it upside down. Not sure how they do that, but I've seen one or two pictures. We actually have a label on top of our skimmer that says this side up now. That label also includes a QR code to an installation video. So if an installer has any questions, it walks them through about a 5-minute install video. And again, there's 6 inches of pipe there. So this skimmer's not going to float very far. So probably a good thing since they got it installed upside down. It's still going to drain the pond for the most part, but pretty poor install. And the last thing on this is skimmers are not maintenance free. This is a different skimmer, but it's got vegetation growing out of it. So anytime you see vegetation growing out of the actual skimmer itself, you probably got a problem. So in this case, there was a big root ball inside the skimmer, and this pond wouldn't drain because there was a trickle coming out instead of what was supposed to be. Any any questions before we go into the next portion of the project, of the presentation? All right. So next, we're going to start talking about permanent use of skimmers. And I'm going to launch another poll real quick here and just say, have you ever considered a skimmer for permanent use? I'm excited that the yeses are going up every time we do this. So that's great. Majority are no, which we understand. Got a few in here that are saying they've considered it but haven't done it. That's great. And then like 7 that have said yes. I'm in that, share those. So nearly a quarter of you have used it. So that's awesome. So that's something we've been pushing for a while. So for those of you that have considered it or not, let's kind of talk about why you wouldn't do that. So really, let's talk about a dry basin, right? Dry detention basins are probably the most common post-construction BMP utilized. And it depends on the area. If you're in the coastal or have high groundwater, you use a wet one. But most places we're dry. So once construction's done, you're going to remove the skimmer. You're going to put in a low flow orifice installed at the bottom, and you're going to release that first flush, right? That's typically our water quality is based on our first flush model. And you're going to have to do something to keep that from clogging. But again, we're taking that water out from the basin at the bottom where we're trying to settle all the sediment. Again, basins rely upon the natural settling of sediment particles, right? They're going to travel from the inlet to the outlet. Hopefully they're going to start settling before they get all the way to the outlet, but we're going to see a big, volume of that sediment show up at the outlet structure. And we've already talked about how skimmers release the cleaner water from the surface. It's become the standard in majority of the country during construction, and studies have shown it's very effective. Typically skimmers easily achieve 80+% TSS removal. So if it works so well during construction, wouldn't it make sense to consider it for post-construction as well? So this is a quick case study about how the skimmer can help with maintenance. So this is a pond that was in severe disrepair. So this is actually after the timber had been cut out, and I mean timber. There were 6 and 8 inch trees growing in this basin. It hadn't been touched in about 20 years. And you can see here, there's some orifices that you can see for outlet, but it's holding water and a lot of debris, and it didn't have a low flow orifice. At least we couldn't find one. And so skip over here. So this last picture shows, it turns out there's a 2 inch orifice 6 feet below the now bottom of the pond. And so we ended up redesigning this pond. We had to do it as a pilot project with Greenville County, where it's located. And unfortunately, the pond had some extra volume, which is kind of rare. But we went in, we closed in the old orifices. You can see in the concrete here, created some new ones. And instead of going back with that 2 inch skimmer or 2 inch orifice, we put in a 5 inch skimmer. And because it was a pilot project, we had to monitor it monthly and show the county that it was working. So this is kind of photos from each month. About a year later, the owners decided they were going to maintain the pond. They cut the debris from the banks, but they didn't get it out. And they had about a 5 inch rain in just a few hours that washed all the debris down to the outlet structure. And there's a little skimmer sitting down amongst all the junk. The good thing is it drained the pond, right? Even if it had clogged, you would have been able to get to that pretty easily and shake it out and get it to drain versus trying to get to a 2 inch orifice here. Kind of hard telling this picture. This is about 12 feet. These are 6 foot riser sections. And so that's maybe 8, 9 feet of depth. So if water couldn't drain any lower than here, and you had to go pull, clog out or unclog a 2 inch outlet structure, that would be a job and a half, right? It probably requires scuba gear, be very dangerous. So if nothing else, just for maintenance, even though it's going to enhance the water quality and help with with trapping the sediment, we highly recommend skimmers, at least on the maintenance side. So if you're going to put the skimmer in and it's going to be part of your post-construction, we got to know how to model it in your post-construction hydrology software, right? HydroFlow seems to be the most common that's used now. It's built into Civil 3D. So most engineers are using Civil 3D, so it makes sense to use HydroFlow. HydroCAD's another one. ICPR, some few others. So, but I think this will help you, you can use the same concept for whatever you're modeling in. So let's look at an actual site. So this was a pretty small site. We had a pre-development watershed and then post-development and a pond. So our site was about 5.5 acres. We had about 3.4 that we were not disturbing, and we had about 2.25 that's being disturbed, and we're putting a little sediment basin in here. This is a commercial site. It's going to be developed in the future, go to an underground detention system, but it was going to be probably years before it got developed. So we're leaving the basin in for our post-construction control as well. So had a study point here across the road. So we also didn't want to, and there was no drainage here. So water's just flowing out of the basin across the road. So we wanted to keep that to pre-development levels. So our pre-development, we had 5.5 acres. Our current number was 59. That's, this is in the upstate of South Carolina. So that wooded site, time of concentration about 20 minutes. Our post-development for the undisturbed portion was staying the same as that. So the disturbed portion was 2.25 acres. We put a curve number of 86 for a disturbed bare earth condition, time of concentration of 7 minutes. So when you're building your basin, you typically do a stage storage kind of thing. So you've got your stage here. So in our stages, we put in points for each data point that our skimmer detail provides as far as flow rate. Oops. You should be one more. No, okay. Sorry. So you put that in, and that's going to give you a place to be able to enter your skimmer flow later. So again, our skimmers give you the flow rate at 0.1 to 4 feet. So you go 0.1, 0.3, then 1/2 foot to 4 feet of depth. So when you build your structure, first thing you do is your riser structures. We have an 18-inch, excuse me, that's your barrel going out. So you had an 18-inch pipe going out. You've got a 6-inch orifice in the riser structure. We've got our riser here. So it's about 3.6 feet tall. And then we have a rectangular weir in the riser structure. And then kind of the secret sauce here is this user-defined column. So this is where you manually enter your skimmer flow rate. So that's why we put in our stage over here. So we have each stage, and we can build in that flow rate curve by manually entering the flow rate at each stage. Now, again, this was done as an example. There's not a huge difference in flow rate per foot. So if you decide to, hey, I'm comfortable putting in maybe the 0.1, 0.5, and then go into a foot, that's fine. Whatever your engineering judgment it feels comfortable with. So when you do that, if you go over 4 feet, there's a couple of different options. If your basin's over 4 feet of depth. Number one is you can just kind of maintain that 4 foot flow rate because most skimmers have kind of stabilized their flow at about 4 feet. If you want to, you can extrapolate, say, the last 3 data points. Or if your basin's really deep, let's say you got an 8 or 10 foot basin, you can go back and use our design tool that we went about before. You can set your pond depth to the full depth of the pond, and then put in your volume here for the full pond depth. So you would adjust these numbers as well to be the top length and width at the top of the pond, bottom, obviously still the bottom of the pond. Make sure your calculated volume is pretty close to what that actual pond volume is based on your CAD. It's going to break up that into 20 different flow rate increments. So whatever that number is, it's going to be broken up into 20 different increments. And then it's going to give you the flow rate for each skimmer. Now, this is our 2-inch skimmer with a 1/2-inch orifice. So you're not seeing much of a change in flow rate here. But as you get into bigger skimmers, like the 4-inch, 6-inch, 8-inch, you're going to start to see a fairly significant flow rate difference from the bottom to the top. You can then use that to plug into your hydroflow model. So when you look at hydroflow and you look at your schematic of your riser structure, normally you'd see a low flow orifice down here. You're not going to see that in this because you're using that user defined. You're going to see your 6-inch orifice here, rectangular weir, and then top of the riser. But when you look at your stage discharge, you've got flow coming out. So that's your skimmer flow based on your user defined going there. And then other orifices kick in to the top of the riser and merge the spillway. So you can tell from your stage discharge that it is functioning properly and that flow rate's being calculated. Any questions on hydroflow? I know I'm going kind of fast here to kind of make up for the late start time, but okay. Got one question in chat, concerned with the permanent use of the skimmer. The HOA doesn't clean it when it gets clogged. Then remove it down the road, outlet structure won't have quality orphan. Well, I agree with you. But maintenance is just a part of any pond. Um, you know, in the past, I had a pond maintenance business I was involved in, and there were some really, really, really bad ponds. And we do know that enforcement really varies depending on where you are. Some cities, counties, they're out there every year. Some, I think Greenville County tries to go by every pond every like 2 to 3 years. And some places they're like, we'll get to it if we got a complaint. So I do think the skimmer's easier to maintain than like a low flow orifice just because it's going to have sediment build up there. But maintenance is certainly an issue. The other thing is we are developing, and we'll talk about this as we get into the last section here, a network of qualified maintenance contractors across the country. And so, if you have a need for that, let us know. We might have somebody in your area. We're still in early developing that, but we may have somebody in your area that can help. So, all right. Now, this is something that's pretty new. Unless you've attended one of our webinars before, you probably have not seen this. But we're going to talk about a new method for water quality. So we're going to do advanced skimmer modeling here for filtration-based water quality. So we've developed a new filter that goes around our skimmer. So we've got two stages. We have an outer layer that's basically a debris guard, removes the larger particles. It's a polyethylene fabric. We have an inner layer that is for smaller particles. It's a non-woven fabric called Absorbit. It also absorbs hydrocarbons. It helps some with metals. Just because it gets so much of the sediment out, it'll help some with phosphorus and nitrogen that are attached in particulate form, not dissolved. And then all that drains through to the skimmer. And we have had this tested now and for TSS removal. Right. Next one. So it took a while to develop this. So we had research and development underway for a long time to develop this product. We're still under that. In the future, we're going to add filter media that's going to help focus on hydrocarbons, pollutants, working on the nitrogen phosphorus. That's a little harder one to tackle with just a filter. But this was our prototype that we had out in the pond for 2 years before we decided that this was working. Once we felt good about the pond model, and then you can even see here, this is in the pond. There's less turbidity inside the filters than outside. And this is the actual outlet. So you can see that's relatively clean water. Now, I wouldn't suggest drinking it, but, for what's coming out of a pond, and this is that same pond we showed that had all the debris and stuff in it. That's kind of become our sandbox playground. But our third-party testing has confirmed we got over 90% TSS removal. That's to an ASTM standard. And so when we did our testing, we used TRI Environmental. They're a pretty well-known, well-respected company to do environmental testing. They tested 2 versions of our skimmer, and there's an ASTM standard called C1746 for sediment retention devices. One thing I like to point out when we did our testing, obviously the skimmer is going to be in a pond, right? So you typically pond's going to have a forebay. You're going to have some travel distance from the inlet to the outlet. You may have some vegetation. There's a variety of things in the pond that are going to contribute to TSS removal. We wanted to find out what's just the skimmer and filter doing. So we set this up so the test tank, so the sediment-laden water is being introduced right here within about a foot and a half of the outer filter. So there's no travel distance, there's no forebay, there's no anything else. So we're just water's coming in, going through the filter and through the skimmer. I will say the filter is only 3 feet deep. So, and the test tank was about 4. So water could go under the filter and then come up to be discharged. In that case, we are utilizing gravity, kind of a settlement, because there's not enough flow in the water to bring that sediment particle up from over 3 feet deep up to the skimmer to get discharged. We've now installed this commercial version in our same pond. So this kind of gives you, that's that same riser structure, just kind of looking back. You can see how steep the banks are, how big the pond is, and a lot of junk and debris just accumulates here. This basin is about 40 acres. It's heavily developed, mostly commercial, and most of it's old, so it doesn't have any prior doesn't have much stormwater management in it. It's mostly just storm drainage system that just contributes here. And the inlet pipe here is, I think, a 60-inch pipe. So it has pretty big, large amount of water coming in. Got a couple of comments on here too, just while I'm answering. So we do, with our standard, we talked about the comment is bring the barrel closer to the shore for ease of inspection. So in our standard detail, if you go back to that, we actually do call out for the skimmer to be located parallel to the dam, so it's easier to get to and maintain. Also, we know that in some areas they'll install a valve so that you can release the water by hand. You allow the water to accumulate in the pond, give it some time to settle, and then release. I don't know of anywhere that's required. It's definitely a good practice. However, it's also dependent on a person. And so if you get a really big rain at night, you got to have some way for that water to get out and make sure it doesn't overflow. So here we go. But this is our final version. That kind of gives you a good look at what this looks like. That's our 4-inch skimmer. This is inner skirt's about 5 by 5, and outer's about 8 by 8. So it gives you some idea. So if you do use the filter post-construction, you may not want to put it right up against the dam. You need it kind of out the pond, depending on what size you do. So last thing here we're going to talk about is benefits of filtration versus settlement. So one of them is the peak rate of discharge can now be based on your filter treatment flow rate up to whatever your first quantity storm event is. So what I'm saying, instead of the first flush event, so typically first flush is like 1 inch to 1.5 inches of runoff, and we release that slowly over 24 to 48 hours. If your filter can handle a higher flow rate, let it go because the filter is treating it, and you can go up to that first quantity storm event, which is probably your 2-year storm in most cases. Some areas may have a 1-year storm or scour, so erosion. I forget what they call it. A couple of different things they call the smaller storm events. So you may be limited by that, but in most areas, that's your 2-year storm. So if your skimmer can handle your 2-year storm flow in your pond, now you're treating up to your 2-year storm event. So again, the filter treats 100% of runoff from the storms up to the peak rate of the filter. So that helps on the large storms, but also on the small storms. What happens when we get, say, a 1/2 inch of rain over 6 hours and it hadn't rained in 3 weeks? Well, there's a tremendous amount of pollution that's getting washed off into that basin, right? But our basins are designed to pond when they get inch and a half of water almost instantaneously. So if that 1/2 inch comes in over 6 or 8 hours, there's very little ponding, and all of our treatment's based on ponding, so therefore there's very little treatment. In this case, the filter is going to treat those small events and treat the larger events. And again, the filtration media can be customized to target specific pollutants of concern. So we've already built in some hydrocarbon treatment into our material we're using now. In the future, we may be able to incorporate other media to tackle specific pollutants of concern. So that was really why I use filter. So why would you use a combination of a skimmer with a filter? So again, your skimmer can be sized to control the peak rate for the lower storm events. So depending on the size of your site, your skimmer can probably control your 2-year storm for you. The skimmer is going to increase the filter efficiency by withdrawing from the surface where the water is cleaner. So again, we're going to be trying to treat that water in the upper level of the water column primarily, and not necessarily everything at the bottom. And then the skimmer is fairly easy to access. You're going to have a rope on it, pull it to the side for maintenance, and you are going to have to change the filters. They don't last forever. There's some challenges to using skimmers with filtration. Like we said, filters are going to be prone to clog over time. Will require some maintenance, periodic cleaning or changing. Your skimmer's got to be durable. Okay. A lot of skimmers are made of PVC, and that's not going to be suitable for permanent use. That PVC is going to degrade over UV over a few years. So you really need something that's more permanent use. Our skimmers are an HDP product, polyethylene, so they're going to last 20 plus years. And then our biggest challenge today is there are no established standards or basis of design and permitting based upon a combination of the pond and filtration. We have talked to several states. Some states have given us the okay Those of you in South Carolina and Georgia, we pretty much got a green light to use them there. North Carolina, it's difficult. They have a proprietary system, a testing plan that's harder to go through. Texas, pretty much, honestly, kind of Wild West. They leave it up to the engineer. Ohio, we're definitely getting there. We've got several of the MS4s that have said they're fine with it. We haven't gotten a blanket from Ohio EPA yet, but we're working on that. And along those lines, this year we're working on getting NJCAT approval. We don't have that yet. We just have the ASTM testing. We are working with our testing company to come up with protocols on what we can do in order to get NJCAT. And that's going to open up, I know for a lot of you engineers, that's kind of the gold star, right? If it's stamped, approved by NJCAT or NJDP, then most areas will accept that. So we'll be getting that out to you. Our goal is June, but it's a long process. We'll see what happens. So real quick, we'll wrap up today. Talk about how the difference in modeling for post-construction, the volume-based first flush, again, released over 24 to 48 hours, versus a filtration-based, based on the flow rate of the filter. Let's see what the pros and cons are for each method. So we're going to do a sample site. We're going to say it's 5 acres. We're going to do a pre-development condition. Let's call it wooded, curve number 55. So very little flow coming off the site, pre-development. Post-development, we're going to do a shopping center here. We're going to do a little 5-acre commercial center, curve number of 92 for it. First thing we're going to do is do our pre-development flow rates. So based upon the 5-acre wooded site, assume the time of concentration about 48 minutes. And we're going to focus on our smaller storm. So our 2-year storm would just be a 0.72 CFS. Then we'll go to 3 CFS, 5.4 for 25, and about 11 for the 100. But again, we're going to really kind of focus on our 2-year storm. So the next thing we want to do is we're going to do our water quality, volume, and our post-development flow rates. So based upon the 5-acre commercial site, I assume time concentration 10 minutes. We're going to calculate that water quality storm event. All right. So now in South Carolina, it's water quality is 1 inch of runoff for a dry pond. Georgia's 1.2 inches, 1 inch in Tennessee. I think it's either an inch, inch and a half in North Carolina. I think Indiana's inch and a half. It does vary state to state. So whatever your local state requirement is for this, but let's just, in South Carolina, it's an inch. So that would equate to 18,150 cubic feet for our water quality storm event to generate that runoff. So I went in, trial and error, ran the storm events to see what would generate that. And it came out with a 1.73 inch, 24-hour storm to generate that water quality volume based on our, curve number 92 site. So for flow rates, we've got 7.2 CFS for the water quality event. This is, pre-pond, it's what's flowing to the pond. 19.72 for your 2-year storm, and 10-year, 25, and 100-year you can see. So most engineers have a spreadsheet they use, and it's similar to this. If you have something different in your area, I'd love to see it, but this is kind of what the feedback has been. So we've got, again, 5 acres contributing area. We got a dry pond, so we got 1 inch of volume. And so we're going to determine the orifice size to drain that 1 inch of volume in 24 hours. So we got a requirement to hold it 24 hours. That's going to be an average flow rate of 0.21 CFS. We factor in the average head, so on, run through the spreadsheet, come out with a 2.6 inch storm. Now, one thing about this is we're draining this volume in 24 hours based on this information. That volume does not hit the pond instantly, right? It's going to come in and come out over some period of time. Depending on your type storm event, it may come in pretty quickly, but again, it's going to flow in and out. So we're not going to poof, magically have that full volume in the pond. So run this through calculation to see what it would be like. So again, our water quality volume is 18,150 cubic feet, which equates to an elevation of about 113. So the bottom of our pond's 110. So it's a 3-foot depth. And so based on that, I put in a 3-inch orifice just above the 3-foot depth to control the 2-year storm, an 8-inch orifice at 2 feet more to control the 10-year storm, and the risers doing the 25. So run that through our hydrology program. Our peak flow rate for our water quality storm is 0.25. Again, we were shooting for 0.21, so that's pretty close. Got a peak elevation, 12.5. Notice here is using 10,700 cubic feet of volume. we have 18,000 cubic feet of volume required that we're not allowed to put an orifice below. So we've got about, what's that? Close to 6,500, 7,000 cubic feet of volume, say maybe 7,500 cubic feet of volume that we're not utilizing in the pond. 2-year storm rate is 0.81. Our pre was 0.72, so it's a little bit higher, but 1/10 of a CFS increase is probably okay on your 2-year storm, again, depending on where you're located. So the option here is let's go with a skimmer to control the 2-year storm. So again, our 2-year storm rate was 0.72. And these peak flow rates, these are based on at a 4-foot depth. So our 6-inch skimmer with a 6-inch orifice has a flow rate of about 0.78 at 4 feet S. So let's try to run it and see how it comes out. This is the detail for our filter. So again, we've got an outer panel, 3 feet deep. That's basically just a woven geotextile. It's a Mirify 402. The inner skirt, again, it's the adsorbent. It actually is in 2 panels and it's slit. So the idea is that the slits are offset 3 inches. So water is going to kind of weave through the panel. What we found is this material, although it has a pretty high flow rate per square foot, that's, when water is going through vertically, when it's going through horizontally, it just doesn't flow very fast. There's not a lot of pressure to pull that water through. So we end up doing the slits and doing 2 panels. That also creates more contact time because the panels are put right together. So it kind of lets the material, it's a little sticky. So it grabs the sediment and does a better job of pulling the sediment out. One thing to point out is the inner skirt and outer skirt lengths. The lengths vary in direction for some skimmers. So the 6 and the 8 and our 8-inch max, those have pretty high flow rates. And in order to maintain our ratio of area and our length, with that, as the flow rate increases, some of these get pretty big. So our 8-inch max has a peak flow rate of about 1.8 CFS. So that's chugging some water. The outer skirt is going to be 16 feet in this direction, 46 feet in this direction. The reason it's only 16 here is because typically we don't more than about a 20-foot section of pipe here. As the pond fills, the skimmer is going to rise. It's going to come up at a 45, so it's going to get closer to your outlet structure. And so we don't want the filter hitting the outlet structure. So that's why we have it set up that way. This is the pond detail. So again, you like to set this thing where it's easy to get access to, but you also, especially if you use the big skimmer, need room for that filter to move around, not get stuck on the bank. So, based on the shape of your pond, specify where you want it in there. And here's all your pond information again. So as we run through this model, again, we got that same volume. Well, now our water quality flow rate, because it's going through the skimmer, is releasing at 0.7 CFS. Remember, our traditional first flush model was only 0.25. So we're letting water out nearly 3 times as fast there. And by doing that, we're only using 7,600 cubic feet of the volume. So again, our first flush volume was 18,000 cubic feet. Now we're getting that job done in 7,600 cubic feet. The skimmer's controlling the 2-year storm. Okay, so we don't have that 3-inch orifice up here. Our next orifice is the 8-inch, and that skimmer is controlling 2-year storm. So we got a slightly reduced flow rate. So we're only like 0.06 CFS higher than our pre. And because the skimmer is controlling 2-year storm, we're now treating all the flow up to that 2-year storm event. And then if you compare these, I'll skip to the next one, really it's the percentage here. The difference in storage required for traditional pond versus the filter base, 30% difference for water quality event, 14% and 12%. So you're actually treating the storms, treating more of their annual rainfall, the tiny storms all the way up to a 2-year storm. You're treating it to a higher degree, tested to 90% TSS, and you're doing all that with a smaller pond. So if you have any clients that fuss about having a smaller pond, let me know. We only had one so far, and that was down in Charleston where they needed dirt for sites. They were digging the pond out to create fill. So in summary, our skimmers are less prone to clog than orifice located at the bottom of the pond and often require less maintenance to keep the pond functioning properly although maintenance is required. That's going to be a very important part of it. Skimmers can be a very effective way to retrofit existing basins. I didn't touch on that, but we have hundreds, if not thousands, of basins out there that were designed prior to water quality requirements. If you go in and try to put in a first flush model with that, typically they don't have time. They don't have volume to do that. So if you can maintain that flow rate by using the skimmer and just add the filter, that's a great way to retrofit that basin. Let's say if you're redeveloping a site and you're having to do water quality because you're redeveloping, instead of adding a bunch of water quality devices or catch basin filters, whatever, be a very, very cost-effective way to get that done. And then because you're doing the surface withdrawal, you're releasing that cleaner water from the basin for enhanced water quality. Again, the use of the skimmer with the filter has been tested per ASTM to confirm 90% TSS removal. Again, we talked about how it treats more than annual rainfall, small storms, and large events. And your filtration model is going to reduce your pond size. So last question here for our group. Launch that one. Before we already had some people that had considered it, but now that you're aware of the benefits of skimmers for permanent use, what's your thoughts? All right, so I got a few that say yes, it's about the same that have used it. Those of you say maybe for the right project, yep, I fully agree with you. And then we got two that are no, it should just be set to be temporary. And well, now we got three. That always happens. I'm not going to argue with you. You're the engineer of record, so you do what you feel is best for the site, but at least you're aware of it. So for those of you that say maybe or yes, what I would say is that if you have a site that you're considering, please let us know where that site's located. Let us go to the reviewers in those areas. We've sent our information out to majority of MS4s and pretty much every state that's on this webinar. But as you know, reviewers are very busy, and hopefully we've got some review folks or regulatory folks on the call today. But they're very busy, and honestly, they may look at it, but they're not really going to look close until there's a need. And so, if you're thinking about using this in your area, just shoot us an email, say, "Hey, we're thinking about using it in whatever city, county. Here's the reviewer." We'll do that groundwork for you. We'll go to them, say, "Hey, we got an engineer who wants to use it here. We want to make sure that you're okay with it before you do that full engineering design." Because last thing we want you to do is spend your time and then the engineer say, or the reviewer say, "Nope, not going to allow it," and then you wasted your time and cost your client time. So then we'll wrap up here real quick. We're just over our time. We're right back about where we started. This is our website, rymarwaterworks.com. We've just done some updates on it, so you'll see some things there. At the top now, we have a new design tool. Love some feedback on it. Basically, you go in, enter your pond information. It'll create a custom PDF for you to put on your plans with the correct orifice size information, flow rate information, all that for you. So that just launched this week. So please let us know your thoughts on that. We have some resources and training. So we always keep a webinar on there. Usually it's within the last 3 to 4 months or so. We'll be updating that probably the next month or two with a new one. We also have a training series. So we break down what we've gone over today into small chunks of 10 to 15 minutes each. So you don't have to search through the full webinar to find what you're wanting. So that's very helpful. This is if you go to our engineer spec pack, that's a zip file. It's got the skimmer details, design tool, test data, everything you need there. It's got sediment basins and it's got water quality. They're all in different folders. So if you just extract those to wherever you save your details, it'll organize that for you. So you'll have all the information on Marley float and the water quality filter easily there for you. Again, our product's made of HDPE. It was always intended to be part of the permanent outlet structure from the time I first came up with the idea. Has no moving parts, just a little pivot. Again, it's got this debris guard on it, so water enters below there, helps to minimize that. It works in, we'll call it mild frozen conditions. You have an inch or two ice. Like I said, Lynn's in Minnesota. I'm sure that if there's any skimmers on basins there, they're not working at all right now because it's like 6 degrees. But yeah, it will in the southeast or Texas, wherever you're going to work pretty much year round. Our orifice is unique. We give a an orifice plate with standard sizes. And then this video here on the top shows how easy it is just to take it out, rotate it, change the orifice size. Got this little nub right here that helps secure it in place. It also makes sure that the orifice is always centered over the outlet so it drains properly. Each model is going to have 3 to 5 flow rates, and they've all been third-party tested. Our skimmer was redesigned about 5 years ago, 6 now, so that it always floats level. Before, it's a little top heavy. We moved the center of gravity low, so it always stays level in the basin. And our 6 and 8 inch have handles to make it a little easier to move them around. They're pretty heavy. They weigh about 200 pounds. Takes 2 people to move it in most cases. So nice to be able to have the handles to move it around there. We do have 6 different models. So thing I point out here, we have 2 8-inch versions. So we have an 8-inch, our standard 8-inch uses a 6-inch pipe. And then the 8-inch with the 8-inch pipe is we call it 8-inch max, has the highest flow rate. That's nearly double what most other 8-inch skimmers are. The reason our 8-inch uses a 6-inch pipe is to counteract or minimize the buoyancy. Our biggest challenge when we design these, engineer the product, is the buoyancy of the pipe connecting to the skimmer. As the skimmer rises in the pond, that pipe becomes mostly air, and a 20-foot stick of 6-inch or 8-inch pipe has a tremendous amount of buoyant force to lift the skimmer up. That's why ours are as heavy as they are, because we keep that pipe completely submerged. And then I know we're running real tight. I'm going to go real quick. This is our VersaWaddle. This is a design for use on hard surfaces. So it's inlet protection. What it does, main function is really a flow diverter. So when you've got a subdivision and you've got that, don't have the final asphalt, you got a little lip on the curb, put these down. It'll create a little eddy in a J shape to collect some sediment, but it also kicks the water over the curb so your catch bases actually function. The best benefit of it is designed to be driven over, so passenger vehicles, no problem. And then challenge pretty much any other product on the market that claims this to handle a dump truck running over it. Most of them will be toast, the erosion eels or straw wattles, any of that. They're not going to recover from that, but VersaWaddle will stand up to that. Also really good for shopping centers. Like this is an inlet in the middle of a parking lot. It'd be hard to provide protection that's not getting hit, but it does there, and in a sag there, lets the water through slowly. So thank you all. Appreciate everyone's patience as we got a slow start today. Appreciate you hanging out. This is being recorded. We'll have it up on our YouTube site this afternoon or tomorrow. Any last questions anyone has? Someone had to jump off. Appreciate the thank you. Again, I just want to emphasize, if you're using the water quality filter or want to use it, please shoot us an email and let us know. And if we can ever be of assistance. I am an engineer, been doing this for, well, the video earlier, you can see my gray hair. I've been doing it for a while, about 30 years. So if we can be of assistance in your project, please don't hesitate to use us as a sounding board. You can scan the QR code to go to our website. If you need a PDH, please email us. Yep, somebody just asked about PDHs. Email to info@rymarwaterworks.com. I know we have a lot of people on here that may be EITs or non-engineers, so the PDH isn't required, but email us info@rymarwaterworks.com. We will get you a PDH certificate out right away. Those of you in Indiana, we are approved in Indiana. We just got our approval. I know Mr. Spots is on here. We're working on Georgia on the EnviroCert approvals. We've submitted for that. Working on a few others. Most areas of the country don't require the course to be approved. If you're in an area that does, please let us know, and we're happy to go through that approval. I think all of you agree. This is a technical presentation. We're not trying to just be salesy here and just sell our product. We're trying to help you with your designs, provide some new information. So thank you all. I will end that for now. Stop the recording. Richard, you may have to stop the recording. I think that's on you. So, okay. Thanks everyone for joining us. You'll have a great rest of the day.